The James Webb Space Telescope is the world's most powerful and most significant space telescope. When the telescope was built, it was said that it would allow scientists to look back 200 million years after the Big Bang, to see how our universe looked. Images of some of the first galaxies ever formed will be captured by the telescope. It will also be able to look inside dust clouds to see where new stars and planets are forming, as well as examine the atmospheres of planets orbiting other stars. And with the recent discoveries made by the telescope, it might actually be true. Last year, the $10 billion James Webb Space Telescope was successfully launched into space on Christmas Day. The world has been waiting for its first images since its launch, images that NASA claims will give us a new perspective on the cosmos. Although we will have to wait a few months before seeing these incredible views, NASA recently released Webb's first in-focus image of a single bright star captured during the mirror alignment process. In this video, we are going to talk about James Webb Telescope's stunning image discovery and what is it the image. The $10 billion James Webb Space Telescope launched in December and arrived at its station nearly 1 million miles, 1.5 million kilometers to be precise, away from Earth in January. Since then, it has been hard at work preparing to conduct the science for which the mission was created. The agency announced on Wednesday that the spacecraft completed its fine phasing on March 11, marking another important step in its preparations. The telescope has also met all of the optical specifications required by engineers and is reliably delivering light to its instruments. As a result of this accomplishment, NASA is confident that the observatory will meet its science goals sooner than thought. According to the statement, the new image that the James Webb Space Telescope focuses on is a star known as 2-mass J17554042+6551277. This star is a new objective for the observatory. The commissioning process had previously focused on a star in the constellation Ursa Major, that is about 241 light-years away from Earth, named HD 84406. But if you look closely at the background of this image, you will notice something even more intriguing, a taster, if you will, of what this incredible telescope is capable of. Other stars and galaxies that the agency did not identify can also be seen in the background of this image. Webb is the first space telescope to use segmented primary mirrors, which are used by some of the world's largest ground-based telescopes. The massive mirror of the James Webb Space Telescope, which stretches 21 feet across, contributes to the telescope's 6.5 meters observing power. The observatory's designer split the golden surface into 18 individually adjustable hexagonal segments, because a mirror of that size could not be launched as is. Yes, the Webb Telescope is the height of a 3-story building, and the length of a tennis court. It is so large that it must be folded origami style to fit inside the rocket. The 18 hexagonal beryllium mirror segments that make up the primary mirror unfolded after Webb successfully made it into space. Is not that amazing? Mirrors collect and focus light from distant stars, allowing space telescopes to see. The larger the mirror, the more details can be seen by the telescope. Launching a massive, heavy mirror into space is extremely difficult. As a result, engineers created 18 smaller mirrors that fit together like a puzzle in the James Webb Telescope. The mirrors fold up inside the rocket before unfolding in orbit to form one large mirror. What is the significance of the gold mirrors, then? A thin layer of gold aids in the reflection of infrared light by the mirrors. One of the most challenging tasks the Webb control team had to face, since the telescope's launch, was aligning each segment into a single smooth reflecting surface. However, according to a recent NASA press conference, the primary mirror is now fully aligned to within a fraction of a human hair's width, and performing even better than expected. Despite the fact that many more alignment steps and tests must be completed before Webb can deliver its new view of the cosmos, this entirely focused image is the highest resolution infrared image ever taken from space, giving us a glimpse of how powerful Webb is. The alignment of those segments has been fine-tuned by mission engineers for weeks in order to bring the universe into focus for the massive observatory. NASA stressed that the process is not finished yet, but the team has completed the most complex and nerve-wracking steps. To aid engineers during alignment, the agency also released a selfie image taken with a lens designed to photograph the primary mirror. According to NASA, the team's other major preparation step is to calibrate the instruments aboard the observatory, which should be completed by early May, and the telescope will be able to begin science observations. Understanding the origins of the universe is very important. The observatory's top science plan is determining the habitability of exoplanets and determining the impact of mysterious dark matter on the cosmos. Talking more about the image, 2 mass J17554042 plus 6551277 is the name of the star in the center, and while it is the brightest object in the image, emitting streams of light across the universe, it is nothing special. It's just an ordinary, anonymous star with just the right amount of brightness to ensure that the mirror alignment is accurate. If you want to call it that, you can call it a test star. What's interesting is what's going on around the star. The background is covered in a spray of tiny dots, as if someone spray-painted white and golden streaks on a black paper. But why are these specks interesting? Because these specks are distant galaxies that have never been seen before. They are billions of light-years away. These mysterious, faraway galaxies turn this crystal-clear image into a so-called deep-field image, which captures the universe's most distant objects. Now, if this does not interest our science geeks, we don't know what will. Some of the most famous deep fields, such as this one, took the Hubble Space Telescope days, if not weeks, to obtain. The James Webb Space Telescope, on the other hand, will be able to achieve the same results in just a few hours. Although the James Webb Space Telescope is 100 times more sensitive than Hubble, the two observatories do not image at the same wavelengths. Hubble specializes in visible and ultraviolet light, whereas Webb works in the infrared spectrum. The cameras on the Webb telescope are sensitive to solar heat. Webb has a sun shield to protect its instruments and mirrors, similar to how you might wear a hat or visor to block the sun from your eyes. The sun shield on the telescope is about the size of a tennis court. Is not that huge? The difference in temperature between the telescope's sun-facing and shaded sides is over 600 degrees Fahrenheit. The construction of this masterpiece always leaves us in awe. It's essential to keep in mind, though, that this is just a practice image. Once the observatory is fully operational, spectacular views like those captured by Hubble over the last 30 years or so will be available. But, despite the fact that it is a test, it represents the start of what we will soon see. The James Webb Space Telescope will allow us to see the first galaxies formed, only a few 100 million years after the Big Bang. It has the potential to change the way we think about the universe. And I, for one, am looking forward to it. The next great observatory is honing its vision, and is well on its way to solving the universe's mysteries. Planets don't just live in our solar system. Thousands of planets orbiting stars, other than our Sun, have been discovered by scientists. These are referred to as exoplanets. The James Webb Space Telescope will aid in the study of exoplanet atmospheres. What do you think of the Webb Telescope and the new discovery it has made? Let us know in the comments below. Could the building blocks of life be found in the atmospheres of some exoplanets? We will find out soon enough. Thank you all so much for watching. If you enjoyed the video, please tap the like button and share it with your friends. Subscribe to our channel to see more videos like these. See you in our next video. Till then, happy exploring.